Okay, last one I'm gonna record here. I'll probably record another one tonight at home, but I want to go ahead and get this one out of the way. I only got one more and then one to re-record if I get through this one. That's the IDOR Defensive Depth one, which is IDOR one that access control one that we could talk about next time. Should be a shorter one. Then maybe record that other one. But here we go. Slides. Cool. So today we're going to talk about defense a little bit of some of the things that we've been talking about for a bit. Right? So before today, we did learn some defense things, right? Like we learned that same origin policy protects confidentiality, not integrity, right? Like we learned that CS cross-site request forgery exploits integrity. We learned that we can protect against that with CSRF tokens to verify intent, that these are intended to do it, and that we could use same site cookies to limit what gets sent where cookie wise, right? So these are kind of like the protections and some of the things that we talked about, protect against some of the things that are going on here, but they're not sufficient, right? Why isn't same origin policy enough? Well, it's actually not enough for the opposite reason, or the reason you think it is. Modern web applications talk to a lot of things. They use third-party APIs, third-party services. They use APIs that may be on different domains. They use things like Cloudflare, like we've been using for the class to hold our DVWA, right? They use content delivery networks, microservices. There's a bunch of pieces that all need to talk to each other, and same origin policy breaks a lot of that. So how do we protect against it? And how do we fix it? Well, the first thing we're going to talk about along this line is we're going to talk about something called CORS, right, which is cross-origin resource sharing. It is the methodology that we tell the browser that it can ignore same origin policy, right? It's basically we tell the browser what origins and that we're willing to let read our responses, and we do that because those origins may be loading scripts and other things, and they may be doing things, or we may be loading content from somewhere else, and we need to talk to it via our JavaScript, right? Like, or we need something else to talk to our content via JavaScript, right? So if you were providing a third-party API, then you would probably want to use this, right? So CORS is cross-origin resource sharing. It's a browser protection mechanism, security mechanism that allows cross-origin access to the DOM and other things. The server sends some CORS headers, tells the browser what to do, and the browser enforces that policy, right? So it's basically indicating to us what we are allowed to trust. Right, so it kind of looks like this, right? Like the main header, and there are a stack of them. We're only going to talk about a couple of them, right? Like CORS, how to deal with CORS is deep and complicated. I recommend you use ChatGPT or Claude or Google to help you figure it out if you're actually implementing it in production, right? But the TLDR here is we add a access control allow origin calling https trustedsite.com, right? That means trustedsite.com may read the response, right? We're telling the browser that, you know what? If the origin here is trustedsite.com, it can go ahead and read our response, right? So again, this is controlling reading the responses. It doesn't help or doesn't deal with anything with CSRF because that is requests, right? There is a methodology to say that we can allow credentials to pass, right? We're going to allow it to talk to things like an authorization header and credentials. And it is a configuration to say the following: access control allow origin star, access control allow credentials true. Almost every browser will reject this. Why? Well, think about it logically. Access control origin star means that you're telling the browser that any origin can read our data, and you're telling it can read credentials. That is a gun to shoot yourself in both feet with and stumble backwards. And so the browsers are going to protect yourself from yourself, and they're not going to let it happen, right? Because this would basically allow any site to go ahead and read your data. So some types of cross-site origin requests trigger something called a pre-flight request. A pre-flight request is basically an HTTP options request. It's sent with some custom headers, including authorization, right? Or it's sent if custom headers are included. For instance, authorization, right? It's sent if it's not get, head, or post, right? And it's sent if the content type is not one of these simple, the simple types, right? Text plain is a simple type because we're posting plain. XWWW form URL encoded is basically how posts get sent by default, and multi-form data is how posts with files attached get sent, right? If you're not one of those types, or you're not a getter, header, post, or you have custom headers, you're going to trigger something called a pre-flight request. An example request here, the server will send an options request, right, with the origin, with the access control request method saying, hey, we're about to do a post, and hey, we're going to send an authorization header, right? The server will send the options request. The server will reply with the allow methods and headers that we can send, and then the browser decides at that point whether or not we can send the response and whether or not we're actually going to send the request in many cases, right? And if it's allowed, if the access control indicates that those are allowed things we do, then we're going to go ahead and send the request. This is a little complicated. I'll see if I can see in the demo when we go through here in DVWA. So you can see what it looks like in practice, because it makes a lot more sense when you actually read it there. This honestly is one of the more complicated things to get your brain around, right? Because there's a lot of moving parts, there's a lot of back and forth. And it's one of those things that you just kind of have to work through and tinker with, right? Like I've explained it, I don't know, numerous times, and I still have a little bit of trouble getting it. And I still have a little bit of trouble understanding, right? So basically, what happens is we send an options request. If the method is other than get, header, post, if the post has a content type that is not one of the other ones, or we contain custom headers, it contains the origin header in indicating the requesting site. It contains the method of the intended main request, and it lists any headers that are allowed there, right? And then the server are going to send back the headers indicating it's gonna send back the access control headers that the browser can then read and say, you know what, am I gonna be able to read this response? If the answer is yes, then it will go ahead and send the response, and it will read it, right? Like if the server denies it or fails to respond, then the browser blocks the actual request and throws a CORS error, and you'll see it in your JavaScript console in that case. Right, so this basically allows the browser to ask the server, like, hey, you know, the user wants to do this shady stuff, like, are you going to allow it? And the server can reply back yes or no, or give its rules back, and then that tells the client what's actually happening here. Right, so in the case, the response here, right, access control allow origin, we're going to allow from example.com, we're going to allow post, and we're going to allow you to send authorization, right? Like, if we don't get those back, then if they don't match what we're going to send, then we go ahead and we deny the request and we don't actually send it. So how does this differ, and how does this interact with CSRF, right? So like CORS controls who can read our response, right? CSRF doesn't really care, right? Because we don't plan to read the response. CORS is browser enforced, right? CSRF is server logic flaw. There's no validation on the server side, right? And again, CORS is a methodology for us to control or be explicit about where we're protecting confidentiality. And again, with CSRF, we don't really care, right? Like because we're breaking integrity. Right, so that's a very quick, very high level discussion over what CORS is. Man, we could talk about CORS for a while. If you get into blue teaming, this is a thing that you're going to spend a lot of time trying to get right because it is complicated. Cool. So now we're going to talk about, okay, if CORS controls who can read the data, then how do we handle scripts, right? Like we might want to load scripts off of another site, and then we might want some protections against that. So we have another concept. It's called CSP. Our tech people love their acronyms. CSP stands for Content Security Policy. Right? It limits what the browser or where the browser allows JavaScript to be loaded from. Right? It's a response header that restricts what resources, not just JavaScript. It can be object types. It can be images. It basically restricts where we may load and execute content from. This is a direct protection against something like a cross-site script, right? Like we don't want to load scripts from another page that get injected in. So we could set our content security policy so that our script source can only be self, like we see here. Right, so CSP exists because cross-site scripting happens, right? So this is a mechanism for us to do some sort of damage control if we screw it up and we have something here, right? Like this is very common. It's a very common header you see employed a lot of places. As we go through some quick demos at the end of this, you'll probably see that. I'll hit some random locations just so you can see. Right, here's an example policy, right? Default source self, right? So basically if I haven't given it the type, uh, if I haven't given it the like source or image, right? I'm actually, the reason I'm typing here is I'm looking up what type of things we can actually set in the CSP header. We can set default source, script source, style source. So we can load CSS. We can control our images. We can control what we can connect to using like XHR, XML, HTTP requests, and WebSockets. We can control frames, where frames can load, right? And we can give some data about where to send violation reports if people are doing naughty things with this, which is kind of neat, right? I kind of like it. So in this case here, right, default source is self, so we can only load things from our page or the origin that we came from, or the domain we came from. Our script source is also self, but we're also allowing trustedcdn.com, and we're not allowing objects to be loaded from anywhere because we set it to none. That is probably the cool thing, right? Like we don't really need objects. You know what? Flash went out of style a long time ago. We're not going to talk about that. Right, so we actually have this other cool thing that we can do these days. And I've not seen this in production. I actually read about this for the first time when I was putting this deck together for class. We can use nonces with modern CSP. So, like modern browsers implement like a newer version of CSP than the original version that supports something called nonces, right? So you can actually set something like script source nonce dash and then a string, and then only script lines and inline scripting that contains that nonce will execute, right? If we are generating the server side and we're generating the pages on demand, we can stop CSS in its tracks with this, right? Because you will not be able to properly calculate the nonce, right? So the script code just won't run. I think that's really cool, right? It's a little stronger than allow list because it stops stuff from being in the page, right? Instead of just third party chain loaded, right? It protects you can protect your inline script things with this too, right? We also have the concept of doing hashes, which I'm not going to cover here. The book covers it on page 254. This is actually a really neat thing because what it means is it's some limited amount of protection against like a supply chain risk, right? If you hash your scripts and you allow scripts with this hash to load, if somebody goes and changes the script on your CDN, it won't load anymore, which I think is cool. It's a little bit of upkeep. Uh, if you are publishing your own scripts, that works well. If they're third party controlled, it's probably going to be a little tougher to handle that, honestly. If you're worried about it, you should probably host your own scripts and not chain load off third party sites, right? So this is a thing that we can do to provide some additional protection for where we load scripts from. However, it doesn't fix injection vulnerabilities like SQL injection, command injection, right? Like, obviously, that's not what it's intended to do. It doesn't necessarily stop XSS. The nonce stuff can do a very good job of it, but I haven't seen it widely implemented, right? So, because we normally are inline script blocks, then we tend to not be able to stop that, right? Like, that doesn't really help. It doesn't stop backend logic issues in the server, right? And it doesn't replace validation, right? This is basically a mechanism that we can use to limit blast radius a little bit when bad stuff happens and XSS is about to happen. And I'm kind of crushing through this quickly because these were kind of like, afterthought defense things that we wanted to talk about here. The book covers them well, right? I just wanted to give an overall lecture for those of you that, maybe missed this class or are following along at home. talk about 3 other additional security headers here. Right, the first one is X frame options. It protects us against something called clickjacking. Clickjacking is where you might load my frame or my page inside of a frame. I might do this, so some origin things. We can do some neat, fun things with origin, where I'm just gonna wrap your page in my page, but I can set some of the headers and security headers to give me a little more access than maybe I otherwise would have. Right, like so there's some protections uh, uh, that happen there. Uh, cool. Right. So X-frame options deny. Like that's a thing that typically I would like to see in many pages. I really don't want you iframing my page. Right. Like uh, right. The other thing that people sometimes do is they'll put a transparent iframe over a legitimate site. Right. So users click hidden buttons. Right. Like so you can basically stop the ability to deal with frames with these sites, right? You can do deny same origin or allow from, which is deprecated. Uh, Typically, we'd probably not use this. We'd probably use frame ancestors inside of CSP, right? This is like a legacy methodology that this was done with. The next one, and this one is very used in every site, that's HTTPS, should generally do this. HSTS stands for HTTP strict transport security. The header is actually called strict transport security, and what this does is it tells the site that it always has to load via HTTPS, and it will not allow the page to load if there's a cert warning. If your site does HTTPS and you have no plans to ever do HTTP, there's no reason to not be setting this. You should definitely be setting it with preload. Uh, uh, right, like, and the reason we should be doing this is so that, like, you don't fall back with a man in the middle, somebody proxying it. It's some of the types of things you'd get with cert pinning without any of the headache associated with cert pinning. But yeah, it basically tells the site it's only allowed to load via HTTPS. There's really no reason you shouldn't be doing this in almost every case these days. And the last one that we want to talk about here is refer policy. So what refer policy does is the browser handily sends a refer header in almost every request it makes, saying where the data came from, like what page did you come from. That leaks data, obvious to things. It's actually the thing that makes modern ad networks work, although there are other ways that is done these days that are way more nefarious than just refer. But we have a couple of things we can set here. We can set refer policy, no refer, so we're not going to send any refer when we click onto other pages. And we can send strict origin when cross origin, right? So basically in that case, we're only going to send the top level domain, right? That can prevent us from leaking things like page paths for internal sites and other things like that, right? Like you may not want to leak the entire path that you're hitting there. So let's talk for a minute about defense in depth and what that looks like, right? So like if you were designing a site now, right, like you get SOP by default, right? Like we have some ability to change it. Maybe we want to do strict, but I'd leave it alone right now, right? Because I'd probably set cores, right, with the proper headers and where I'm actually expecting stuff to be loaded from. I'd set CSP to indicate where my things can load scripts from. I'd use CSRF tokens in every single case, plus reauthentication on supercritical actions. I'd use same site cookie restrictions to stop me from other sites from being able to read cookies. I'd use HTTP only on those cookies to prevent JavaScript from reading them if there's no reason for JavaScript to read them. That wasn't on this slide, but I would do that too. And then I would definitely, in all cases, use HSTS to basically indicate that we can only load the site via HTTPS. Cool. So I'm gonna move on to a quick demo, just showing what some of these sites, these headers look like in practice. And I'm gonna get out of here and I'm gonna go home. It's almost 5 o'clock on a Friday, and I'm still sitting here doing this for y'all. This button. Okay. The first one I'll go to, right? Like, actually, let me go back over here to Bert because I'm still from the last one, so we're gonna clear everything here. Why no clear history? There you go. Cool. Let's first start with our DVWA. I'm just gonna load the home page here. Look at our response here. Notice a complete lack of any of those headers. That's intentional, right? Like DVWA is intentionally vulnerable. So it goes out of its way to not actually set any of the security headers, right? And I just wanted to demonstrate that to you all so you would see it. Let's see. Sure, we'll load the weather channel. Ooh, potential for strong tornadoes. I've actually not loaded this page, so we're gonna learn here together. Cool. So what kind of security headers do we have here? Well, interesting. They're using Akamai there. We've got some cache headers. So right here, here's some security headers, right? Like this security flag on this cookie for amplitude.variant. That looks like some sort of third-party thing. We're setting some country. Look at this. Look at this. It sent a rough idea of where I'm at. That's really interesting. They're setting my location inside of a cookie. That's kind of interesting. Also secure. And notice none of these cookies are HTTP only. That's interesting. Okay, cool. Now we're getting access control, allow credentials false. So we're not going to send credentials. We're going to allow access control, allow headers. They're going to read star, right? That's obviously going to stop authentication headers because allow credentials are going to be set. And we're going to allow get, post, and options. Pretty standard. And we're going to allow origin from star. That makes sense for something like the Weather Channel. There's not really a lot of risk there associated with that. Again, we got some more cookies getting set here, right, from other third parties. These are probably all ad affiliate related things that are getting set here. And that's it, right? Like we don't really have a whole lot of cookie policy stuff here. Let's go find something more interesting. We probably called an API. Look at that. We called an API. So now we're calling API, so we should start to see some more, right? Cool. So now we've got a lot different data here, right? So what host did we call here? It's weather.com/API, right? So this is probably a different backend server. They're probably proxying API somewhere else, right? So that's super interesting to note here. We can see, oh, it's webcakes. Cool. I don't know why we're loading stuff from EU, but that's cool, right? Like notice X-frame options. We're only going to allow frames from the same origin for clickjacking protection. We've got XSS protection. I don't know what that header does. I'm going to have to look it up later. We've got cookies again, right? Now we've got access allow credentials true in this case, right? So we're going to allow it to send the credentials, which probably makes sense because we probably have some sort of, if I log in, there's probably going to be some sort of like JWT or something that could set here, right? In this case, we're going to allow these headers explicitly to get set. Interestingly enough, right, accept authorization, those are pretty standard. That's URL. Content type, that's fine if don't match. E-tag, they don't want to lose their ad tracking. That's what E-tag does. Cache control, like location, blah, blah, blah. Right, we're going to allow those, and we're going to allow from the origin of weather.com, right? So only weather.com can read the data from this third-party piece here, right? Again, look at that, more geocoding. That's sadness. I mean, yeah, interesting. So now you can see we're loading some weather data here. Let's see, what else? Do we got anything else interesting here? That's calling Google, trying to find data about us. What's Google say? Let's look at theirs. So now we're seeing our first cross-origin resource policy, right? Cross-origin. Report to, there's a report to for issues, CSP, right? Here's a content security policy that says we require trusted types for scripts. We have a report URL, which basically will report back if CSP failures happen. And yeah, so you can see modern web, right? Especially APIs, you start to see a lot of these headers sent. This is interesting here. There's API v1. Now we're calling API v2. API v2 is running varnish. That's cool, right? Like we allow headers authorization, so we want to be able to read the authorization, but not really a whole lot more there. Of note, look at this right here. I wanted you to see it. We got one. This is a pre-flight request. Right, so we did a pre-flight request here indicating that we were about to hit these things, right? And we were going to send a GET with the authorization header, right? It came back and said 204, no content, 204 is okay. And then you can see down here that we actually did the GET. Did we have an authorization header? No, we did not. Oh, no, we did. API key. Interesting. So they must have set that API key. Why do you think I'm a Linux? I'm not Linux. I'm a Mac. Oh, no, this is Linux. Ha, that's funny. Cool. So yeah, you can see that we sent our authorization API key. That was probably provided to us via JavaScript because this is going to be almost certainly an XHR, XHTML request from the browser, right? So here's our refer. I talked about refer policy, right? In this case, access control, we're going to allow origin star. That's interesting. And then I forget what vary authorization does, right? But it's basically, I don't know, this is setting some postal code trigger stuff. Who knows what it does? And then look, right, we're loading a CDM here, right? So again, because of the CDN, we are going to need to do access control out origin, right? We're going to need our CSP header here to allow what's actually allowed to run the scripts, cross-site, course, we're going to allow get and post or getting options from weather.com. That's cool. Right, like actually that doesn't really appear to be doing anything. That's probably just some sort of marking, right? Like that's just a get with a PID. But you can see like a modern web app loads a lot of stuff. Let me find a nice spa for us to load. I'm thinking. I don't know if this is one or not, but we're gonna look at this briefly and then we'll be done here. Look at all the stuff that modern website loads. Sickening. Eventually, I'll find. Here we go. Here's our get. Get data 301, right? Basically, because it loaded HTTP, right? Upgraded and secure request. Notice we sent an HSTS, right? Which is going to preload. So we will only ever load this via HTTPS in the future. It did redirect us to www. This is served via CloudFront, right? Like, again, we've got some cookies being set here. We've got a strict transport, again, that we're sending back. Not really because this is the main page. We're not really going to see a whole lot here in the way of security headers other than secure on the cookies. However, on the back end, as we start loading Eventbrite static stuff right here, you're going to start seeing this is loading out of S3, right, via CloudFront, right? So you're going to start seeing access control out origin. Because this is S3, they don't really care where it loads from. But now you're going to start seeing some API calls here, home API, right? And once you start seeing API calls, then you should start seeing some security headers. Not really any in this case. But let's see if we can find. Here's a pre-flight request for initialize, indicating that we're about to send a post, right? And we're going to send these additional headers of note here, content type, blah, 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 right? Like we want to send all those. And here's our origin. We get back a go ahead. Here's our allowed headers, right? Like that pretty much matches what we're about to send. And we're going to allow origin star. So we went ahead and sent the request down here, which was a post. We're posting some stuff here, right? This is interesting because this is telling me what features are enabled on the site for me with a set of rules, right? So these are basically client flags controlling what I can and can't do in it. Again, some API calls here. I would expect these to have some amount of security headers in them. Not really a lot. That's just doing geocoding. Yeah, so I mean, it's really kind of a mixed bag. There's not really any, but notice there's a CSRF token here. Haha. CSRF tokens for cookies, don't really dig it, but I guess if it is HTTP only, it might work there, right? Like typically would not want to see CSRF tokens set as a cookie. I guess they're doing it here. But anyways, just wanted to show you guys basically a high level walkthrough of what these headers look like in practice. It's really hit or miss whether I see them. There's still a lot of sites that don't properly implement this stuff, and there's a huge opportunity. Just last night, I was doing some light pen testing for one of the applications in our space, and I came across misconfigured CORS policies, misconfigured CSP, right? And I reported it all up to them, and they're going to work on fixing it. It's hard if you want your site to be able to be vetted from a lot of places. So next time, I'll try to record this tonight. If not, I'll get to it tomorrow so that it's up before the end of this weekend, so you guys working on the midterm can have it. So far we've assumed the server's okay and it does the right authorization. So what if it doesn't? We're going to talk about authorization. We're going to talk about IDORs and broken access control, and that is it. And I will talk to you later. See ya.